This is Ayush for 8 puzzle solver. This is my packages searches under which there are different classes of different searches. The menu node will be basically your input, easy, medium or hard, your searches. Everything that I have done is on strings, so any manipulation, everything will be done on strings. The input output will be on strings. First we'll go to breadth first search. Breadth first search is the first in first out, that's why we use Q node. Here over here our root node, which is right over here, we set the current node as the root node. Then the whole thing goes through a loop, a while loop, which checks the current node state to goal state. If it's equal, it'll come out. If not, it'll go through it again and again. This frontier dot size is basically for the size of the max size of the queue. Now what we do is we add the current node to the visited state so that we know that we have visited it. This successor is basically the children. It gets the children of this current node. Basically this is all what's happening here. Over here, when we add a child to the frontier, that means we are adding the child to the queue for the evaluation. After once this fostering the children's are over, we go to this current node, we retrieve and remove the last node, that first node that we have, and we put its value to current node. Once the whole thing is done, we print the solution. Next we go to DFS. DFS is basically last in first out, that's why we use stack. A different thing that we have done over here is, like, for UCS we have a priority queue. For priority queue, for comparator, we have used another class called priority comparator, which is basically over here. What it does is it checks the node in the priority queue. If they both are the same, the one with the lower cost will be kept and the other one will be removed. A star is basically heuristic 1. Misplaced styles, here it checks what all uh, what all the states of the current state and the goal state are not equal. If they're not equal, the misplaced style will be incremented by 1, and once the loop is over, it will be sent to child dot set total cost. Set total cost, what it does is it takes the current cost and it adds it to the h1 cost. So basically that's what it does. Once this child's cost is set, it is added to the frontier. The whole process goes up again and again. Frontier is retrieved and removed from the current node. Is like that node is retrieved and removed and put into current node, and the whole thing happens again. Now what we'll do is we go to A2. A2 is basically the same thing but with Manhattan distance. We go to the backbone of the program, which is node. Basically the successor um, children nodes, the getting of children nodes happens at node. What it does is it gets the current state. After that, it state in that state we check the index of 0. If the index of 0 is 0, it can only move right or down. That's why we move it either to 1 or to 3. If it's on index is 1, we move it accordingly. The whole thing is like set up like that. After that, like in the node, we have a different print solution where it prints the solution of the node. Now what we'll do is we'll run the program. As you can see over here, yeah, so choose a difficulty level. For example, I choose 1, easy, and we go for breadth first search. Everything is like right up here. The initial state, which is this, we move 0 up, this comes 0 right, this comes 0 up, this comes the whole thing. Once we get to the solution, we get a prompt where it shows the length from the initial node and everything. Next, we will run it over again. Now in this case we'll go to medium, and for medium we'll go for uniform best. This is the output. Next we will go for hard, and we will start with 6, that is A star with H2. Everything is like right over here. We get the space taken, total cost, time and the movements. That's all. Thank you.